So now that you've kind of reviewed how to do these multi-step equations, how to do more than one step when you solve, we're going to go a little bit deeper here, and today we're gonna just do a quick video on how to maybe make some problems that involve fractions a little bit easier for you. So just as an example, let's take this equation here. We're going to do 3, hang on, get rid of that. We're going to do 3y over 7 plus 5/7 equals -1/7. Now, yeah, you could solve this by subtracting 5/7 from both sides and then dividing by 3/7. But you notice how they all have the same denominator. We can do something that's called clearing the denominator that will make this problem a lot easier. So watch what happens when I do this. If I take this whole thing and multiply that by 7, now to make this accurate, I also have to multiply the other side by 7. So in order for this to stay as an equation, I really have to make sure, so here's my equation right here, in order to have that stay as equals, I have to make sure what I do to one side, I do to the other. Otherwise, it's no longer equal. Notice when I do this, what's going to happen here? This is the same thing as 7 over 1, right? Well, if that's 7 over 1, then this 7 will cancel with that 7, and it will cancel with this 7 as well. So what happens here is I have 3y. Well, let me just write it this way. I'm going to have 3y divided by 7, and that's going to be times 7 over 1, right? And like I said, that cancels. I'm also going to have 5/7 times 7 over 1, and that's going to cancel as well. Equals, on the other side, -1/7 times 7 over 1. That's going to cancel as well. Notice this is called clearing the denominator, because when I multiply these, 3y, let's see over here, I got 3y times 1 is 3y, plus I have 5, this just ends up being 5 times 1, which is 5, equals, and then over here, I've got -1 times 1, which is -1. Notice all the denominators are now 1 times 1, 1 times 1, 1 times 1. So all the denominators are gone, are cleared away, and that leaves me with this equation that's a lot easier to solve. I don't have to worry about common denominators. I could just subtract 5 from both sides. I have 3y equals -6, and then divide both sides by 3. Y equals -2 is my final answer. Okay? That's really easy when the denominators are all the same. Let's take a look at one other example here. See if I can. So either way, make sure you have a common multiple, and then you'll be able to clear that denominator out of there. Okay? Take a look at another example. This one's a little bit trickier, but the same process still applies. I'm going to do 2p over 3, so that's 2/3 times p plus p over 4, same thing as 1/4 times p, minus 1/6 equals 7/2. Take a look at all the denominators here. I've got 3, 4, 6, and 2. In your mind, you should be thinking, okay, I know that those are all factors of a number. They all kind of go together. If I think about what the greatest common, if I got common denominators here for all of these, the common denominator would be 12. So instead of this 3 times 4 is 12, 6 times 2 is 12. Instead of getting a common denominator, I'm going to clear the denominator. So I'm going to go ahead and multiply this whole thing right here. This times 12, and this times 12. Okay, so I have 2p over 3 times 12 over 1 plus p over 4 times 12 over 1 minus, or we'll just do plus -1/6 times 12 over 1 equals 7/2 times 12 over 1. It's kind of repetitive, but we'll get there. Okay, so this 3, I'm going to divide this by 3 and this by 3. I'm going to get 4 here. So this is going to end up being 2p times 4 is 8p. Okay, then let's go over to here. I'm going to divide this by 4 and this by 4. So I end up with p times 3, which is plus 3p. Over here, I have divide by 6, divide by 6. I have negative 1 times 2, which is plus negative 2. Or if you want to change that back, that's the same thing as minus 2. Equals, and then on the other side, I'm going to divide by 2 and divide by 2. And then I have 7 times 6 is 42. Now I'm going to combine like terms. I've got 8p and 3p is 11p. Minus 2 equals 42. And I'm just going to add 2 to both sides. Continue to combine like terms by taking that 2, put it over with the 42. So I have 11p equals 44. Divide by 11, divide by 11, and p equals 4. A little bit easier to solve. Might take I think it might take you the same amount of time, but less chance for you to mess it up if you have trouble with fractions. So there's another option for you if you see any problems that have fractions. Remember though, all of the denominators need to have a common multiple, in this case 12, in the last